Hello friends, today we will discuss about push down automata. We can understand a push down automata as a finite automata with stack. So a PDA can do the following things. Number first is we can perform a push operation on a PDA, and another operation is pop operation. Third thing is that we can also check the empty condition of the stack with an initial symbol, stack symbol, that is Z0. Fourth is we can read the top symbol of the stack without any pop operation. And fifth one is we can make state changes. So these are the following operations which we can perform on a PDA. So for basically we use this, we were learning about finite automata, and in finite automata we have we know that it works for regular languages. So it is more powerful, PDA is more powerful than a finite automata because it has an added memory that is termed as stack. So for every it works for context free languages. So for every context free language there exists a PDA, and it is more powerful than finite automata. The reason I have told that it has a stack, a memory associated with it. So basically technically we can say it is a 7-tuple machine. M is equals to Q sigma tau transition function delta Q naught Z naught and F. So Q is the set of states, sigma is the input alphabet, third is tau is the stack symbols. Then we have a delta transition function. This transition function is basically does the mapping from some state to some another state. So Q is the set of states and sigma is the next input that we want to take, including epsilon, and tau is the stack symbol, and it will map to some next state, another state, by applying some operation which may be push, pop or no operation. So these are the basic things. Q naught is the initial state, F is the final set of states, and Z naught is the initial stack symbol. So we'll see all the operations we have talked about, like push operation. We'll see how the transition is done while doing a push operation. So for push operation we have state Q naught and we have an input A, and we have a initial stack symbol that is Z naught. We can also draw the diagram for this. Here we have the empty stack with initially we have Z naught, and we want to do a push operation. So for this push operation we have the state Q naught and input alphabet is A, and Z is already in the stack, that is the initial symbol. So we are inserting a A. So for inserting a we will do a state change, that is Q1, and this Z naught and A comes in this stack and it will become AZ naught. So this is the first operation, push operation. Next operation we can do with push down automata is no operation. So for no operation we have some state Q naught and we have a input A, and we already have a we can say we have B in the stack. B is already present in stack. So this is the structure of the stack, this is Z naught, and B is already present in the stack, and we want to do a no operation. So for this no operation we can make a state change. We are moving from Q naught to some Q1. Input symbol is our A and top of stack is B. So we can see when we are doing a no operation, then the stack will remain unchanged. This B will not be replaced by any symbol. So we have Q1 and B. Third operation is pop operation. Pop operation. In this, we can remove any element from the stack. Let's suppose we have a stack and a B is in the stack and we want to remove this B. So for this we have some state Q0 and we have an input symbol A and top of the stack is B. So for removing this B, we are doing the pop operation. Here we will change the state, we'll move from Q0 to Q1 and we want to replace this top symbol. So we'll replace this B with an epsilon. So B will be popped from this stack. So now we don't have any input. So these are the major operations that we will do in push down automata. So now we will solve a problem of push down automata, and we have a language L is equals to that number of A's must be equal to number of B's, for equal number of A's and B's. So first of all we'll write the algorithm for this. So our algorithm will be we can have many conditions. First is that the string accepted by this PDA will start by A. So we have a stack having Z0 initially and a is inserted into the stack. So let's suppose that first element is A. So first condition is this. So for this problem another condition will be that the string must start by B. So a B can also come. So we have another stack with Z0 and B is the starting symbol. Another condition for this will have that A is the initial symbol and a B is followed by A. So for this we have the stack Z0, A is already present in the stack and a B is following this A. Another condition we can have is B is the initial symbol and A is following the B. So Z0 is the initial symbol and B is the first symbol in the stack and A is following this B. Another condition we can have is, fifth condition is that B is already in the stack and a B follows this B. So for this we can have Z0 initially and B is the first symbol and we are pushing another B into the stack. Another case can be, the sixth condition will be that A is in the stack and another A is following this A. So we have this type of stack that Z0 is initially in the stack, A is there and A is following this A. So we have 6 conditions. So we have to write the transition rules for all these 6 conditions. So first we'll draw the transition diagram, and with the help of that transition diagram we'll write the transition rules. So the transition diagram will be like this. We are on state Q0 and the first symbol is A and stack top is Z0. So the output will be AZ0. This is for the first condition when the first input alphabet is A. Another condition will be that the first symbol is B input symbol is B and Z naught is the top of stack. So the output will be BZ naught. So these are the two conditions. Third condition is that we have A already into the stack and we are pushing a. So for this the output will be AA. Another possibility may be that a B is in the stack and next symbol is also B. So we will push the B into the stack. The fifth condition may be that already a is present in the stack and the next alphabet is B. A is already in the stack and a B comes, then we will follow a pop operation and will replace this A with epsilon. Similarly, we can have another case that A comes, A is the input symbol and we have B onto the stack. So we'll replace this B with epsilon. So these are the 6 conditions that will come across for solving this problem. So after all these transitions, when we don't have any input, then we'll move to a final state. So for that final state, we don't have any input. We have input such as epsilon and Z naught will be the top of stack when the stack is empty. Initial symbol will be Z naught. And we'll move to another state, that is Q1. Our final state, we can also say it as QF by having no operation. So Z naught will be the stack symbol. This is acceptance of PDA with final state. Now we'll write the transitions for this. So the transition rules are number first is we are on state Q naught and input symbol is A and stack top is Z naught. So it will give us the output as Q naught A Z naught. Next transition is that we are on state Q naught and first symbol is B and top of stack is Z naught. So we'll move on Q B Z naught. The third condition will be that we are on state Q naught and we have an input A and we have already A as top of stack. So for this we will push one A onto the stack. So we will have Q naught AA. Another condition will be we have state Q naught and B is the input symbol and B is the already on the top of stack. So for this we will push one B onto the stack. So we have the output as QBB. So these are the push operations. And these two are also the push operations. Next, another condition we can have is we have state Q naught and the input symbol is B and we have a top on the top of stack is A. So for this we will apply a pop operation and we will move to state Q naught and this A will be removed by epsilon. A will be replaced by this epsilon. Another condition, the sixth condition is that we are on state Q naught and input is A and stack top is B. So what we will do, we'll remove this B from the stack. So we have the transitions like Q naught and B will be replaced by this epsilon. So these two are the pop operations. These two are the pop operations. Next, for final acceptance, we'll have state, we are on state q naught and we don't have any input, and z naught is the top of the stack. So for no operation, we'll move to state qf, that is our final state, and z naught is the top of stack. So these all are the transition rules for this problem. Thank you.